The next topic which I would like to discuss is wet corrosion, which is also called as an electrochemical corrosion. The name itself indicates that this type of corrosion usually takes place in the presence of moisture. So here, in the presence of moisture, this type of corrosion takes place. Here, the wet corrosion is also called as an electrochemical corrosion. The reasons behind this to call the wet corrosion as an electrochemical corrosion is when the conducting medium is in contact with a metal, or else the other reason is when two dissimilar metals are connected together and are exposed to the conducting medium, such that one metal which possesses an higher oxidation potential, that particular metal has a tendency to undergo oxidation. So wherever the metal which is undergoing the oxidation, that particular metal acts as anode till the corrosion usually takes place, leaving the other metal unaffected. So these are the two reasons for which we call the wet corrosion as an electrochemical corrosion. And as we all know that in an electrochemical corrosion, there are two regions. One is an anodic area and the other comes the cathodic area. In the anodic area, usually the oxidation takes place, whereas in case of cathodic area, reduction takes place by consuming the electrons. So in the cathodic area, as I said you, the reduction takes place by consuming the electrons. So they consume the electrons either by the liberation of hydrogen gas or else by absorption of oxygen gas. So here for the evolution of hydrogen gas, if you observe this particular diagram, the iron metal when it is exposed to the acidic medium, the iron metal, when it is exposed to the acidic medium, as soon as the metal is being exposed to the acidic medium, the rate of corrosion would be faster. So only faster will be the rate of corrosion. So the metal undergoes oxidation. So as the iron metal is undergoing oxidation, it liberates ferrous ions as well as electrons being liberated. So here the electrons which are being liberated tends to move towards the tends to react with the H plus ions of the HCl solution, thereby forming H2 gas. So in this way, the hydrogen gas would be liberated when a metal is in contact with the acidic medium. The rate of corrosion would be faster in acidic medium rather than that of the basic and neutral medium. So that is how the hydrogen gas would be liberated in case if a metal is reacted with the acidic solution. So here the acidic solution which I have taken is HCl solution. So iron metal when it is exposed to the acidic solution, either it may be HCl or H2SO4 which contains H plus ions in it. So as soon as a metal is being exposed to the acidic medium, the metal undergoes oxidation, liberating ferrous ions and electrons. Those liberated electrons tends to react with the H plus ions of the acid, forming H2 gas. So in this way, the hydrogen gas would be liberated. So here, in case of liberation of hydrogen gas, we could find a large anodic area and a small cathodic area. As I said you, like the rate of corrosion would be faster in case of a metal reacting with the acidic medium. So as soon as a metal is being exposed to the acidic solution, faster will be the rate of corrosion. So in that case, you find a large anodic area and the areas which remains unaffected. So that areas are cathodic areas. So small cathodic area and large anodic area is being found in case of liberation of hydrogen gas. So that is how the hydrogen gas would be evaluated when a metal being exposed to the acidic solution.